Now we're going to do a different. Now this says metric unit of capacity. Another way to say this would be volume. Do you remember doing area and volume and that kind of stuff? Probably middle school you did that kind of stuff. Okay, capacity is the same kind of thing. This is what you use for volume in the metric system. We use liters. What's the thing you probably use every day that's in liters? At least I do. I pull it out of the fridge. What is it? Soda, right. I pull out a what? A 2 liter, right. Get a 2 liter bottle of soda, all right, or Pepsi. That's my favorite. I love Pepsi. So I get a 2 liter bottle of Pepsi, and I told my last class that I'm so old that I remember back in the day before we even had 2 liters, they would just sell it to you in like the 20-ounce bottles and stuff. And I remember they came out with 2 liters. I thought, oh, that's so cool. But guess what the 2 liters were in? They were in glass bottles. They were these big, thick, heavy glass bottles. And you'd bring them home in the bag, and they weren't plastic bags. We had those big old brown bags, old school. And then you'd carry them home, clink, clink, clink. And sometimes they break, and sometimes you have these big old 3-liter bottles, and they came in these big, thick, glass. It was crazy. Now you never see those anymore, but anyway, that's what it was like back in the old days. Back when I was a kid. All right. Anyway, but that's a liter. So you have a general idea in your head how much a liter is, right? It's a 2-liter bottle, but half of it. In fact, Pepsi or Coke, they have like 1-liter bottles, don't they? I think Pepsi used to call it like a big slam or something like that. But you can go to, you go to Wawa or something, and you can buy a 1-liter bottle. So you have a general idea what 1 liter looks like. Now, it takes 1,000 milliliters, okay, to make 1 liter. So a milliliter, is it bigger than a liter, or is it smaller than a liter? It's smaller because it takes 1,000 of them just to get one of these. Follow me? Back to the other countries. If you go up into Canada and you want to get gas, you're not gonna go up and say, okay, I'll take 10 gallons. What are you gonna do? You're gonna not say gallons, but what? Liters. That's right. You'll see the prices, and it's a price per liter, not per gallon. All right. If you go to other countries and see that kind of stuff. On my honeymoon, we went to Niagara Falls. We stayed on the Canadian side, and we drove up to Toronto one day, and we got gas. And I'm like, wow, look how low the gas prices are. But it wasn't that low because it was for not a gallon. What was it for? It was for a liter of gas. So it was actually more expensive where we went than it was at home, and I was all excited. It just took me a minute to think about it, but anyway, enough of that. Let's do one. All right, let's go. Let me find a good one here. This is kind of like that first problem that we did. I wish they'd give you a different type of example. That's all right. We'll do this anyway. It'll be good practice. 3.7. Now, they use capital L to liters, but I don't know why. But I always use a lowercase l. I don't know why they put a capital L. I've usually seen it lowercase l for liter. So I'm going to do that. Is that all right? And we want to change that to, put a question mark. We want to change 3.7 liters, and you want to change it to milliliters. All right, which is pretty easy. It's basically a one-step problem. Let's just do it real quick. 3.7 liters, put it over 1. Now we're going to multiply it by a unit multiplier. Liters is on top, so you put liters on the bottom. We're going to change it to milliliters, so that goes on the top. Whatever you're changing it to has to go on the top. Now, how many milliliters equals how many liters? Make sure you put the right numbers. Right, 1,000 milliliters equals 1 liter. Don't put 1,000 liters down here. That wouldn't make sense, would it? All right, it sounds silly, but that happens a lot. People do that a lot. They get mixed up on which, the top or the bottom should they put it on. Just make sure that makes sense. 1,000 milliliters equals 1 liter. And now we're done, aren't we? Pretty much. Kind of like that first problem we did earlier, right? With the meters and kilometers. All right, so it's 3.7 times 1,000. You move it 3 places, and it's almost the same number. What was the other one? It was like 4.7 something. 4.2, right? Okay, and so there you go, and that's your answer. Notice what I did. See all this stuff right here? See all that? That should be on your homework. I don't want to see, number 1, 3,700 milliliters. I don't want to see that. I want to see all this mess right here. You with me on that? All right. Now, I'll say that 100 times during the year, and I'll get so many students hand me just a bunch of answers, and I'm going to turn it back. Sometimes I might not even give you credit for it, but sometimes I'll just yell at you. Not really yell, but I'll get on you a little bit and say, look, show your work. Or guess what I would do that's even worse than yelling? Nah, I'm not going to throw it away. I wouldn't do that to you, but I'll take points off, okay? Take points off your homework for not showing your work, and I'll see that I mean, you ask, I could give you some names of some kids last year that they saw that almost every homework. Show your work, show your work. And if I'm really ticked off one night, right, if the Phillies lose in 16 innings when I stayed up all night last night to watch the game, and I'm grading homework, which, and I'm really mad, then I might take off more than 1 point. I might take off 2 or 3 points. You never know, all right? So show your work, and there you go. I try not to grade if I'm mad, okay, because just sometimes you never know. All right, let's do this one. Look, these are the worst ones for me. I always forget these. Do you? Or do you memorize these things? I always have a hard time remembering these things, and so this is good for me, so it helps me remember a little bit. Look, 1 cup. And you use this stuff all the time, right? Anybody cook? When I was a kid, I used to cook all the time. I'd make cookies and cakes and all that kind of stuff. So anyway, yeah, we use cups all the time, and ounces and pints and all that good stuff. Look, 1 cup. When do we get out of here anyway? 1:40, 5 minutes. Okay, I can do this. Watch, 1 cup equals 8 ounces. 1 pint is 2 cups. 1 quart is 2 pints. 1 gallon is 4 quarts. Don't you like the metric much better? Absolutely. You don't have to worry about all these different crazy numbers. All you got to do is multiply and divide things by 10 in the metric system. So have I convinced you that metric is better? I hope so. All right. We just got to convince our leaders, and just that transformation, just that turning over to that system and going is the tough part. So let's do an example. Say what? They have tried it, but I don't think they've tried as hard as they should. I mean, other countries, they just go at it. The government just says, all right, we're doing it. I don't care what you say. Boom, we do it, It's going to cost money. I mean, think of all the money it would cost. I mean, changing all the signs, all the road signs that say this many miles. It would be a very expensive thing to do. But I think at some point, I think it would be important to try to transition to that. But it would be expensive. It really would be. It's not that easy just to say, let's all go metric. Equals blank milligrams. Oh, I don't want that. I'm looking at the wrong example. That has nothing to do with cups and pints and all that good stuff, does it? Let's try this one. Let's go 4 gallons equals blank pints. We're going to change it to pints. Okay, this is one of those double ones because look, do I have a gallon to pint conversion up here? No, but I do have a gallon to what? Quart, and I have a quart to pint. So I can do it, can't I? All right, so let's do it real quick. So I've got 4 gallons and put it over 1. I'm trying to get rid of gallons, so I put that on the bottom. And I'm changing it to what? Eventually I'm changing it to pints, but I can't do that right away. What am I going to change gallons to? To quarts. Okay, so put a quart right here. All right, how many quarts, how many gallons? 1 gallon equals what? 4 quarts. Make sure you put the 4 with the quarts. Now we're done with gallons. Gallons is canceled out. Now we got to take quarts and change the quarts. I can change quart to pint. So I put a quart down the bottom. I put a pint up at the top. And how many pints? 2 pints and 1 quart. All right, here you go. Look, the quarts canceled out. Now it's easy multiplication. 4 times 4, 16 times 2 is 32 pints. Again, you might be able to do this in your head, but I want you to get used to doing it this way right here. We good? What's that? I was just 4 times 4 is 16. No, times 2. It's all being multiplied. Nothing's on the bottom. All 1's on the bottom. So if it's all on the top, it's all being multiplied. If you have stuff on the bottom, you might divide, but this is all on the top, so it's all multiplication. All right? Hang on just a second, okay? Because we're almost ready to go. All right, so here's another conversion. This is mass and weight. When you get into physics, technically there is a difference between the two, mass and weight. But as far as we're concerned, look, 1 kilogram, 1,000, right? Kilo always equals 1,000 of something, right? And look, 1 gram is 1,000 milligrams. 1,000 milli, anything, equals 1, right, of that unit. Look at this, though. This is the one that's different. It's the English system, okay, the one that Americans use. 1 pound is equal to 16 ounces. Where'd they get 16 from? I don't know where that came from, but it's 16. 1 ton is 2,000 pounds, all right? The conversions are exactly the same as what we did before, but I wanted to make sure that you see the conversions. Make sure you write them down because you'll need to know those. Because I'm only giving you a worksheet. I'm not giving you all this stuff on a sheet of paper. So make sure you write all that stuff down and you should be good to go. But the conversions, the unit multiplier stuff, right, it's just the same as we did before. It's really not any different. You're just using different units. That's the only thing you're doing. Does that make any sense? All right. I'll keep that up there for a second, and then its bell's going to ring anyway. Let me hand out a worksheet, and then you'll finish that for homework tonight.